Good morning students. Good morning everyone. Today our topic drift and diffusion. Drift and diffusion in semiconductor. Okay. Generally we have in semiconductors we have two charge carriers. One is electron and holes. Electrons and holes. Those charge carriers moving in two ways. One is drift and the one is diffusion. First we discuss about drift. What is drift? When we give external electric field, the charge carriers are forced to move in a particular direction, constituting electric current. This phenomena is known as drift. When we give external electric field to the semiconductor, we give the external electric field to the semiconductor. The charge carriers are forced due to that electric field to move in a particular direction, constituting electric current. Movement of electrons means current. This phenomena is known as drift. Okay. When the voltage is applied to the semiconductor, the electrons move towards positive terminal. You give the field, the electrons present in the semiconductor moves towards positive terminal. At the time of moving, the electron collide with the atoms of semiconductor. The movement of electrons collide with the atoms. After collision, electrons is accelerated and gain some velocity in the direction of electric field. That velocity is called drift velocity. That electron gain velocity is called drift velocity. Let n be the number of electrons present in that semiconductor. Current density J is equal to NE Vd. Here Vd is the drift velocity. But drift velocity Vd is equal to mu Ne. Here mu is the mobility of charge carriers. Here the electrons. E is the applied field. Current density J is equal to Ne mu Ne. In the place of Vd, we substitute mu Ne. Then conductivity J, sigma is equal to J by E. Here J is Ne mu Ne by E. E get cancelled. Conductivity sigma is equal to Ne mu N. Current density due to electrons Jn is equal to Ne mu Ne. In the same way, current density due to holes Jp is equal to Pe mu Pe. Here P is the number of holes, mu P is the mobility of holes. Total current density J is equal to Jn plus Jp. Total current density is current density due to electrons and current density due to holes. So, J is equal to Ne mu Ne plus Pe mu Pe. Here we common E, N mu N plus P mu. That is the current density. Then conductivity sigma is equal to formula J by E. Then sigma is equal to E into N mu N plus P mu P. Okay. Next, diffusion. In diffusion, due to non-uniform carrier concentration, in a semiconductor, the carriers move from high concentration to low concentration. This process is known as diffusion of charge carriers. When semiconductor occurs non-uniform charge carriers, that due to the doping, the carriers move from high concentration to low concentration. That is also movement of charge carriers. In this process is called diffusion. Okay. Let excess of electrons concentration. Uniform means some places having excess electrons and some place low electron concentration. That is the non-uniform. Okay. That excess electrons concentration we assume delta n. According to Fick's law, the rate of diffusion of electrons is directly proportional to minus dou by dou x of delta n. We remove the proportionality, we write a constant minus dn dou by dou x of delta n. The dn is the diffusion coefficient of electrons. In the same way, current density for electrons Jn is equal to current density J is equal to multiplication of charge of the electron with the rate of diffusion of electrons. So minus E into minus dN dou by dou x of delta n, minus minus plus, that equal to E into dN dou by dou x of delta n. Current density for holes Jp is equal to E into minus dP dou by dou x of delta p, minus E dP dou by dou x of delta p. This is the current density for holes. Current density of electrons. Total current density due to diffusion is equal to Jn plus Jp. So E into dN dou by dou x of delta n plus E into dP dou by dou x of delta p. We are adding both current density due to electrons and current density due to holes. We obtain total current density. This is the current density due to diffusion. Okay, current density due to diffusion. Diffusion means charge carriers moves from high concentration to low concentration. This is also movement of charge carriers. In the drift, when we apply the electric field, then the electrons moves towards the positive charge. This is electrons moves and holes also moves. Those charge carriers movement with the electric field, that is the drift. In this diffusion, when concentration varies, in that time the charge carriers move from high concentration to low concentration. This is also movement of charge carriers. That's why current developed. That current is called the diffusion current. The variation of we draw a graph. The variation of excess electron density and with respect to the distance on a semiconductor. This is the graph. Okay, excess electrons delta n. This is not dn, delta n. Difference between drift current and diffusion current. Okay, main difference in drift current produced due to you give the external electric field. Diffusion current is due to the non-uniform concentration occurs in that semiconductor. In drift current obeys Ohm's law. In diffusion current obeys Fick's law. Okay, these are the differences between drift current and diffusion current. Okay, this is a very important 10 marks question, that is conductivity mechanism in semiconductors, that is drift and diffusion. Okay, next we go to problems. In this problem, first problem, the RH of specimen is here given RH, that is the Hall coefficient. RH of a specimen is 3.66 into 10 power minus 4 meter cube per coulomb. Its resistivity is 8.93 into 10 power minus 3 ohm meter. Here you find the mobility and density of atoms. So Hall coefficient given, resistivity given, you find the mu and n. Formula for mu is sigma RH. This is the Hall effect coefficient. From Hall effect coefficient, mu is equal to sigma RH. Sigma means conductivity. The relation between conductivity and resistivity inversely proportional to. So you take conductivity is equal to 1 by rho. In place of conductivity, you take 1 by rho. Already rho given. You substitute RH and rho value, you obtain mobility. Then you find the density of atoms. N is equal to 1 by RHE. This is from RH is equal to 1 by Ne. Hall coefficient RH is equal to 1 by Ne. This is the formula. You substitute in place of RH and E. You obtain density of atoms. This is the first question, first problem in semiconductors. The next problem. The following data are given in the intrinsic germanium at 300 Kelvin. Calculate the conductivity of the sample given Ni and mu E and mu n. Here given Ni, mu E and mu h, or mu h, not mu n, mu h. Intrinsic conductivity formula sigma is equal to Nie into mu n, mu e plus mu h. Here mu is the mobility of electron, h mobility of holes. Okay, you substitute all those values and then you obtain the answer 2.22 per ohm meter. Third problem, on the Hall effect problem, a current of 50 amperes is established in a slab of copper that is 0.5 centimeters thick and 2 centimeter wide. The slab is placed in a magnetic field B of 1.5 Tesla. The magnetic field is perpendicular to the plane of the slab and to the current. The free electron concentration in copper is 8.4 in 10 power 28 per meter cube. What will be the magnitude of the Hall voltage across the width of the slab? So here you find the Hall voltage. Given data is current I is equal to 50 ampere, magnetic field 1.5 Tesla, thickness 0.5 centimeter, width W is equal to 2 centimeters, you change in it meters, and density 8.4 into 10 power 28 per meter cube. Hall voltage formula VH is equal to BI by NEW, BI by NEW. Here B is the magnetic field 1.5 into current 50 by N 8.4 into 10 power 28 into 1.6 into 10 power minus 19 into 2 into 10 power minus 2. Totally 2.779 into 10 power minus 7 volts. This is the very important problem. This is a very important model in these semiconductors. Okay.